Hey there! In this video, I'll share with you an effective way to represent an endothermic reaction on an energy diagram. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. As we use this energy diagram to illustrate an endothermic process, let us be aware that the x-axis shows the reaction progress, the y-axis shows energy increasing, and for this illustration, the reaction is occurring between the reactants AB and CD, and they are forming the products AD and CB. Now, all chemicals will have energy within them, and this is known as the enthalpy of these chemicals. The enthalpy of the reactants is shown by this horizontal line here, and the enthalpy of the products occurs higher up on the y-axis, and it is represented by this horizontal line here. And this is the first indicator that we are drawing an energy diagram for an endothermic process, and that is the reactants have a lower enthalpy than the products. So in order for the reactants to form products, these old bonds in the reactants need to be broken. For that to happen, energy needs to be supplied to the reaction system. As energy is being supplied, the reactants will absorb energy, and so their energy level will increase. This will continue until the reactants reach a state, an intermediate state of instability. At that point, the old bonds in the reactants will be broken. This minimum amount of energy required to break old bonds in reactants is known as the energy of activation. And this can be shown on our diagram from the starting point, the enthalpy of the reactants, to the highest point reached when the reactants absorb energy to break their old bonds. And we will use the symbol E for energy and a subscript A for activation. Once the old bonds have been broken in the reactants, the new bonds will be formed. During the process of formation of new bonds in the products, energy is released from the system. So this will be shown by the line going down until we reach the enthalpy of the products. The enthalpy change taking place in this reaction can be shown by the difference in the enthalpy of the reactants and the products. So this horizontal line here represents the enthalpy of the reactants, and this horizontal line represents the enthalpy in the products. So the difference between those two energy levels represents the enthalpy change for the entire reaction. And the symbol for the enthalpy change for an endothermic reaction is a positive sign, the Greek letter delta, which represents change, and the letter H. So far, we have two indicators that we are working with an endothermic process. The first one being the enthalpy of the reactants being lower than the enthalpy of the products. The second one being this symbol here, a positive enthalpy change. And the third indicator that we are dealing with an endothermic process is that the activation energy is greater than the energy released during the formation of products. Let's now illustrate when we have a catalyst involved. A catalyst is a substance that alters the rate of a chemical reaction without being chemically changed in the process, which means it can be reused. A catalyst will speed up a reaction by creating an alternate pathway for the reaction to occur, and that alternate pathway will have a lower activation energy. So more reactant particles will be able to attain that lower activation energy in order to be changed into products. So let's illustrate that on our diagram. When the particles increase their energy by absorbing energy supplied, the activation energy will be lower with a catalyst than without. And we can use another line to illustrate the new lower activation energy. And we can just write a simple note here, with catalyst. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to represent an endothermic reaction on an energy diagram showing the enthalpy of the reactants and products, the enthalpy change for the entire reaction, and how a catalyst speeds up the reaction rate. Good luck on your exams, and I'll see you next time.